For an extended period, humans have speculated about the nature of existence in alternate universes. Thanks to the James Webb Space Telescope, the most remarkable observatory ever created, that inquiry might finally be addressed. Observing the nearest stellar system to our own Proxima Centauri, which lies merely 4 light-years away, scientists have detected several distinct anomalies emanating from one of its planets, Proxima B. These anomalies, termed artificial illumination, have captivated the imagination of the scientific community. But what do they signify? Do these illuminations indicate the presence of sentient beings on the planet? Join us as we delve into the James Webb Space Telescope's intriguing discovery of city-like lights that could revolutionize our understanding. Currently, Earth is the only known cradle of life. Since the dawn of civilization, humanity has pondered whether life exists elsewhere in the cosmos. To pursue this cosmic inquiry, American astronomers Jill Tarter and Thomas Pearson initiated the search for extraterrestrial intelligence, SETI, project in 1984. The project's objective is to capture extraterrestrial radio signals, as radio waves can traverse vast distances and are more likely to be detected by the 42 radio telescopes comprising the Specialized Allen Telescope Array in California's Sierra Nevada mountains. However, to date, no definitive extraterrestrial signal has been identified. Subsequently, the successful deployment of the James Webb Space Telescope bolstered efforts to study a variety of exoplanets orbiting distant stars. As the largest space telescope ever constructed, stationed approximately 1 million miles from Earth and equipped with exceptionally sensitive instruments, it holds the potential to make groundbreaking discoveries. In the past, no exoplanets were known. However, since then, over 4,000 have been discovered orbiting various stars. As reported by NASA, the universe may harbor millions of such planets. Preliminary indicators of extraterrestrial life beyond our solar system might be found in alien vegetation. The Galileo spacecraft en route to Jupiter turned its instruments back toward Earth and detected a clear sign of vegetation by observing the vegetation red edge, a biosignature characterized by a blend of red and infrared light reflected by plants. For instance, a planet like Earth, covered in dense foliage, should exhibit a pronounced and easily identifiable red edge signal. The James Webb Space Telescope, JWST, aims to measure the red edge of distant Earth-like planets situated in the habitable zone around stars, which could offer crucial insights into conditions beneath an exoplanet's atmosphere. When sunlight passes through a planet's atmosphere, the JWST could potentially detect it as it enters the atmosphere. The missing frequencies would then be observable through spectroscopy, as particles and molecules in the atmosphere absorb specific frequency ranges, creating a unique fingerprint that the JWST can identify. This technique may be employed to ascertain the composition of the atmosphere and whether life is feasible. Life could exist on Earth-sized planets with atmospheres similar to ours, composed of a mixture of oxygen, nitrogen, and carbon dioxide. By searching for elements that are not commonly found, we might be able to detect intelligent life. For example, chlorofluorocarbons, CFCs, compounds used in refrigeration and cleaning products, would almost certainly be detectable by extraterrestrials observing Earth's atmosphere from a distance. If the JWST detects CFCs in planetary atmospheres, it would be a definitive indication of technological advancement. However, life on exoplanets may not resemble life on Earth. Sometimes even ordinary living organisms, such as extremophiles, species capable of surviving in conditions where other life forms would perish, could appear extraterrestrial. These organisms, primarily microorganisms, can endure extreme conditions like temperatures up to 250 degrees Fahrenheit or strong acids with pH levels below 3. Since planets like Earth are more likely to support life than those with extreme temperatures or acidic conditions, it may be prudent to focus initially on those ideal candidates. These planets could have temperatures conducive to liquid water existing on their surfaces and orbit stable stars. Our Sun is classified as a yellow G-type star. These stars are less abundant and generally have shorter lifespans. However, in our universe, the probability of studying planets orbiting red dwarf stars, more common stars with lower luminosities and temperatures than the Sun, is higher. This extended time scale allows for the development of life and the evolution of complex organisms. Approximately 40 light-years from Earth, The TRAPPIST, one planetary system, will be the subject of the JWST's first mission. It orbits a calm red dwarf star with 7 Earth-sized rocky planets. 3 of these rocky planets, located in the so-called habitable zone, could have liquid water on their surfaces. Despite its smaller size and cooler mass compared to our Sun, the TRAPPIST, one star emits light similar to that of Earth's Sunday due to the close orbit of its planets. The most promising opportunity to detect city lights outside our solar system may be Proxima Centauri, a red dwarf star located 4.25 light-years from the Sun. Proxima Centauri is much dimmer than the Sun, so a planet would need to be much closer to it than Earth is to the Sun to support life due to the presence of liquid water. In August 2016, astronomers discovered a planet with 1.3 Earth masses in a habitable zone, a Goldilocks zone where the light intensity is ideal for liquid water. Proxima B orbits Proxima Centauri, but it is possible that Proxima B is an airless, inert planet, considering that it orbits its red dwarf star at a distance of just 4.66 million miles. This close orbit exposes it to intense solar winds that could strip away its atmosphere. Nevertheless, Proxima B receives sufficient sunlight for temperatures and liquid water to exist, similar to Earth. Due to its proximity to its star, Proxima B is believed to be tidally locked, always showing the same side to the star, much like the Moon does with Earth. Proxima Centauri is around 18% the mass of the Sun and emits substantially less light, only 5% of the Sun's brightness. It could appear to be a barren, burned planet. However, liquid water could exist on Proxima B as long as the planet has an atmosphere to retain heat. Since the total energy reaching it from the Sun is only 65% of what Earth receives, the planet may not be especially hospitable to life. Still, it remains the best candidate due to its tidal locking, which means it always faces the same side toward the star, resulting in permanent day and night with extreme temperature variations. Proxima also receives almost 3 times the amount of high-energy radiation that Earth does, including X-rays and ultraviolet light. Due to its proximity to Proxima Centauri, Proxima B is constantly bombarded by high-energy particles during solar flares. Unless it has a protective magnetic field like Earth's, the conditions for life may not be ideal. Still, favorable conditions could potentially make Proxima be a more inviting world. Models suggest that the atmospheres of tidally locked planets may be prone to rapid breakdown due to the freezing out of volatile gases on the night side. Earth's atmosphere can be replenished by volcanic activity, and for planets with strong magnetic fields, similar atmospheric retention might be possible. This atmosphere is less likely to escape. Since we don't have substantial information on Proxima B's volcanic activity or magnetic field strength, we can't definitively measure whether the planet has an atmosphere. However, since an atmosphere suggests the presence of seas, and both together suggest the potential for life, there is great hope to determine whether Proxima B has a complex biosphere. It might have solar-powered charging stations covering the day side to generate energy, lighting, and warming the night side, which would otherwise be too cold and dark for comfortable habitation. The discovery of Proxima B has sparked a rush to determine if it crosses its star's face as seen from Earth. These transits will allow scientists to determine the planet's size and mass, enabling them to assess its density and confirm its rocky composition, offering clues about the materials that make up its surface. During a transit, starlight could pass through the planet's atmosphere. However, the likelihood that the orbit will be in the right alignment for scientists to observe a transit is only 1.5%. The star's tendency to erupt further complicates matters. Astronomer David Kipping of Columbia University states that the star is unstable, as solar flares cause a rocky planet to absorb sunlight and emit it as infrared light. Nevertheless, rocky planets produce a particular type of infrared radiation from stars like Proxima Centauri. Moreover, the James Webb Space Telescope was specifically designed to detect infrared light. Proxima B's infrared signature is critical to identifying the planet's atmosphere. Also, the JWST's infrared capabilities are infinitely better than Hubble's, which would allow it to detect city lights on Proxima B's night side, even if they are as weak as those on Earth. The JWST could identify artificial lighting if it is restricted to a frequency band much smaller than the star's light. Proxima B's day side may be heavily covered with solar panels reflecting starlight. As Proxima B orbits its star, it faces a consistent pattern of day and night with extreme temperature variations. The temperature contrast between day and night will depend on whether the planet is entirely made of exposed rock. If it lacks an atmosphere, Proxima B's temperatures will change dramatically, as the day side will radiate all the energy it receives from Proxima Centauri as blackbody radiation. The night side, on the other hand, would resemble a frozen wasteland. If the temperature contrast between day and night is less pronounced, we can deduce the presence of an atmosphere. It will take the JWST just 11.2 Earth days to gather enough data to detect the first artificial city lights on Proxima B's night side. Lights that could prove intelligent life exist beyond our solar system. Given the study's conclusions, Proxima B may harbor hidden secrets. Perhaps the daytime of Proxima B generates abundant solar energy, and the lights could offer evidence of a vibrant and technologically advanced society. While the presence of artificial lighting on Proxima B would be a groundbreaking discovery, scientists are proceeding cautiously. The detection of such lights could suggest advanced civilization, but there are numerous other potential explanations for these signals. The technology that the James Webb Space Telescope uses to examine distant worlds is still in its infancy, and astronomers are just beginning to refine their methods. The lights detected could be natural phenomena, reflections from surface features like volcanic eruptions, lightning storms, or even unusual atmosphere phenomena that might mimic artificial lighting. It's essential for scientists to continue their research and cross-check their findings. In fact, the James Webb Space Telescope will continue observing Proxima B as well as other potentially habitable exoplanets to build a broader understanding of their atmospheres and surface conditions. The detection of artificial lights would also be followed by years of further exploration to confirm their origins. If the signals do in fact originate from intelligent life, it would mark one of the most momentous scientific revelations in human history. The fascination surrounding Proxima B and other exoplanets is not solely driven by the possibility of discovering alien life. It also touches on deep philosophical questions about humanity's role in the universe. Uncovering extraterrestrial civilizations would compel us to reevaluate the singularity of life on Earth. It might usher in a new age of unparalleled global cooperation, as the recognition of intelligent beings beyond our world could unite people with a common sense of wonder and purpose. Additionally, it would emphasize the critical importance of continued space exploration, motivating nations to develop advanced technologies that would propel humanity farther into the cosmic unknown. At present, the investigation of potential artificial illumination on Proxima B remains an alluring prospect, one that might soon yield answers to the age-old question of whether we are alone in the cosmos. As the James Webb Space Telescope transmits increasingly detailed information, the hope of detecting signs of advanced life becomes more tangible, bringing us ever closer to resolving one of science's greatest mysteries. Does Proxima B harbor an advanced alien civilization? Such a discovery could serve as a cornerstone for future breakthroughs in astrophysics, planetary science, and interstellar communication. As our understanding expands, the next generation of researchers, scientists, and explorers may be the ones to confirm what once seemed inconceivable, that life, in its many variations, might be far more abundant in the universe than we have ever dared to imagine.